Okay, we're going to work the problem 3 here. The cannonball shot from a height of 12 feet, speed of 49 feet per second, angle 61 degrees. We want to find the speed of the cannonball. Alright, so that's the important thing. The trajectory equation gives us information about the location, but it doesn't give us any information about the speed along the trajectory. So that is an indication that we do not want to use the trajectory equation. We still want to sort of draw things out. So let's draw the ground. We're shooting from a height of 12 feet. Okay, so initial angle of 61, so pretty steep right here. And let's see, the 12 feet we got from right there, 49 feet per second. Okay, obviously it goes and hits at that point. It's going to have some velocity there, and that's what we want to find. So, as in trajectory, or as in the projectile motion equations, we want to break it into two parts. So let's first find the velocity in x initially. That's going to be our 49 times the cosine of 61, and punching that into the calculator will give us, come on calculator, 49 cosine 61, 23.76 feet per second. Velocity in y initially, sine 61, .86. Okay, so hopefully you remember from projectile motion that the x velocity stays the same. So that's actually going to be Vx0, so we're halfway done. And this Vy out here can come from a constant acceleration equation. Alright, so we have several constant acceleration equations to work from. The one that does not include time is y minus y0 equals Vy minus Vy squared minus Vy0 squared over 2 times a. Okay, so our final y is 0 if we set our coordinate system right here. Let's come back over here and do that. Our initial y is 12. Fix my mistake there. Okay, the final y is what we want to solve for. The initial y0 was this value right here, 42.86 squared. And acceleration, we're in feet per second, so that's going to be minus 32.2. Okay, so I'm going to use Solver to solve this one. Not too hard with math, but I'll go ahead and plug it into Solver. And I'll move it over here so we can see it. Okay, so I'll move the 12 to the other side. So 12 plus our unknown quantity unknown squared minus 42.86 squared divided by quantity 2 times minus 32.2. Okay, looks like our final Vy is 51.1. Remember, it's actually solving for Vy squared. Okay, so our actual Vy in this case would be negative. Vy is equal to plus or minus 51.09. Okay. And it's downward in this case, so we would choose the negative value, but we just want the speed. So the total speed at the final point is square root Vx squared plus Vy squared. So that's going to be the square root of 23.76 plus 51.09. Alright, so 3.76 squared, 51.09 squared, that totals 3174, and the square root of that, 56.34 feet per second. So that's the V, 56.3. Where am I popped up there? Okay. Common mistake on that problem was to try and use a trajectory equation. You could also work this by finding the time it takes to hit the ground and then using equations for velocity based on acceleration and time. Either way would work.